Okay. Evet, tekrar yeni bir Makina Fakültesi Teknoloji seminerlerden bir tanesine daha başlayacağız. Hoş geldiniz öncelikle. Hem fiziksel olarak salonumuzda bulunanlar hem de aynı zamanda online olarak bizi takip eden değerli dinleyicilere hoş geldin demek isterim. It is my pleasure that to have a guest professor Dr. Elmurod from Tashkent State Technical University. He's going to just give me a moment. He's going to give us a very nice talk about the technology of obtaining new types of paper-like material based on cellulose and filling agents. Before getting into his talk, I would like to give a couple of sentences about his CV and education and accomplishment, what he has done it before. Based on his CV, he has completed his Master of Science degree at Tashkent University of Chemical Technology, and he spent 1 year in Czech Republic to make further research. Also spending a couple of years at Beijing University of Chemical Technology, People's Republic of China. And also, it's good to know that I learned that he learned Chinese over there, and he can speak Chinese and teaching in Chinese. It's a very good, point. And he has published more than 100 articles. And today, he is going to give us that, non-cellulosic formation, cellulosic material based on the green chemistry. This is very important at the moment for industry, for research, for academia. Because, in the last couple of years, people really or industry put really some constraints or standards to get the products based on the green chemistry. Please, Dr. Elmurod, please come over here and start your presentation.
Maybe can I sit or not?
Yeah, you can.
Can I sit?
Yeah, you can sit. You can sit.
Okay.
You can put it over here. Move forward.
Okay. Assalamu alaikum. Hello, ladies and gentlemen. I'm Elmurod EgamBerdiyev, professor for technical science from Uzbekistan. Currently, I work at the University, Tashkent State Technical University. I'm named Islam Karimov. I am very glad to see you. I am pleased to communicate with you. If you allow me, just a little information about my university. My university is a bigger one in Uzbekistan for technical sphere. Just 100 years is history in our university. Our university is 5 faculty, just mechanical engineering and electrical engineering, automation engineering, and geology and mining in the mining engineering and oil and gas engineering. I apologize for you. Just my English is a little poor. That's why it's before mentioned professor. Currently I teach Chinese students in Chinese language. That's why a little bit my English poor. So first, my topic is just obtaining new types of paper-like materials based on cellulose and filling agents. You know that this cellulose is a natural polymer, just obtaining this some kinds of plants or annual and perennial plants. As you all know, the cellulose extracted from various plants in the world. We also use plant cellulose in our research. Unfortunately, due to undevelopment forestry in our country, so that we are obtained cellulose only annual and perennial plants. Currently, we obtain cellulose just paper tree. You know that's maybe just popular just tree, just China. Just next one is next plane is miscanthus. Miscanthus just like this family in the Kamış. So in fact, the areas is a use selective dependent structure cellulose. You can see just you can see cellulose structure just cellulose is very important for paper industry. We need this cellulose is very important for just degree of polymerization and degree of substitution. Since we are usually, can I sit or not? Okay. Sorry. Since we usually engage obtain paper-like materials, wood cellulose is very suitable for research, but there are very few trees in our country. I mentioned before. So have decided to use cellulose from annual and perennial plant of our research. In our current research, we are using paper tree. This miscanthus, we belong to perennial plant class recommended our botanists. So next slide, we are raw materials. This paper, mulberry, I mentioned it before, this paper tree and miscanthus giganteus. Oh, okay, just you know that other country is obtaining cellulose, other plant or bacteria, tunis and algae. So next slide show that our research and quality indicators cellulose obtaining from paper tree. Just I mentioned above the amount cellulose in degree of polymerization. For paper, just these properties and very important and amount of cellulose. Our reaction for very suitable chemicals, just sodium hydroxide. So firstly cooking this tree, after then is obtained cellulose, after then is a bleaching process. Bleaching process is very important for paper-like materials. So in our research, just bleaching process this our research hydrogen peroxide in many countries is carried is sodium chloride. We not use a reagent because you know that chloride is negative effect for health. This process is also very important because if the bleaching process is done incorrectly, the cellulose fiber will be destroyed. This, of course, limited scope use the cellulose. you know that whiteness is very important. This materials and I told you just before polymer degree of polymerization. Okay, in order to further of the research, we use a modern research methods of the particle chemistry, including spectroscopy, thermogrammetric analysis, and etc. You can see just you presented it, yeah. Another side is our research. Just we took the next step in our research, investigate the effect chitosan paper industry. You know that the chitosan is it's you know the structure is chitosan cellulose is similar, but just some kind of group, just amino group, just different. Chitosan is a linear polysaccharide derived from chitin and natural biopolymer found in the cell walls in the crustaceans such as shrimp, crabs, and lobster, and insects and fungi. In our country, you know that in North Sea, that's why we use chitosan from the silkworm chitosan. In our country, science nowadays just obtaining chitosan from the silkworm. Just for step obtained chitosan, this four step. Firstly, preparation and the desacralization reaction and neutralization, purification. Just you can see just reaction, deacetylation. Deacetylation very important for polymers. So just in simple terms, chitosan not only increase our paper, this mechanical properties of paper, but also reduce swelling of water and oil. This property is important. This nowadays this manufacturing the required this properties. I have included the steps, this slide next chitosan of you pay this. You can see the next slide. Chitosan affects the properties of paper. You can see just the slide chitosan properties in paper industry. Firstly, enhancing paper strength, just improving surface properties, and it's very important properties, this antibacterial properties. Next, properties in the environmental benefits. Currently, in every country, looking forward this environmental benefits every materials. Last one is modification papers, optical properties. So you this like you can see just picture. This electron microscope images chitosan solutions of different percentage in incorporated into the paper. It is noteworthy the connection of the solution increases. The Hitazan materials observed is the deposits of the surface of paper. I told before just we use the Hitazan as paper surface. Just therefore we found appropriate use on percentage just solution. Only one percentage Hitazan use the paper is it's possible. Others is impossible. That's why it's paper just not working. So in our research, we added basalt fiber. You know that basalt fiber just inorganic fiber. Just in our country, basalt fiber produced Jizak region. Basalt fiber obtained the basalt mountain. We have two regions has basalt mountains. 1,500 temperature. Just after then is fiber, just mountain. So basalt fiber, what you do, this give us, it increase the flammability of the paper and the water repellency. Just basalt fiber nowadays. In addition, just basalt fiber has another amazing properties, including insoluble just both acid and alkyl. You can see that properties just just next slide. Basalt properties in the paper industry. First, for properties is very important for our new type of materials. Okay. You can see I added basalt fiber. After then is I studied this properties, this paper. Just firstly, just increasing hardness, roughness, and waterness. Okay. Next slide shows that is flexibility and tensile strength. So. Okay, currently, just before I mentioned before, this fiber produced our country. This fiber extracted from basalt mountain. In fact, basalt fiber used make construction materials. You know that this reinforcement. This nowadays our country produced reinforcement from basalt fiber. We used the fiber that were not suitable for reinforcement for research. So as a continued our research, you will interested product of nanocellulose. Nanocellulose is very popular currently, very popular and very suitable for everything that's all the country science is interested in this nanofiber. Nanocellulose is applied in our next step. This my research. Nanocellulose is used paper industry. As you all know, this nano-sized materials are currently this great interested. So we currently try to use paper industry. This being done today is my student, Mr. Shahzad, who is sitting here. He uses nanocellulose for paper. This research is aimed at solving actual problem, obtaining high quality nanocellulose with improved characteristics. I'm develop effective economical combined methods. I learned some kinds of methods from obtained nanocellulose. You can see next slide is in our research aim or propose objects. You can see just okay. Next slide shows that three types of methods, mechanical methods and chemical methods, and you told before just combination methods. We choose, we learn three types of methods. Currently, we use combination methods obtaining nanocellulose. So. You can see there are various methods of production in the cellulose, each has own advanced and disadvantages. You know that every method has advantages or disadvantages. So we are learning this three types of methods, which is combination methods. Why our choose combination methods? Just combination methods in nanocellulose production is promise very optimization methods and cheaper than other. Secondly, just economic effects very profitable for me. Just next slide shows that the mechanical properties, nanocellulose production process, and equipments. The company okay, we need three types of equipments. Galvanization and grinding and ultrasonic treatments. Next slide, you can see just chemical methods for the production nanocellulose, detailed review. Just acid three step obtained. Next slide, combined methods approach and advantages. The combined methods combines advanced and different approach produce nanocellulose with improved characteristics. Includes parameters, this mechanical treatment and chemical modification. This all of this process optimizes product with desired properties. Is important note is environmental safety. I told you before, just currently in our country, just environmental safety products and produce it. So next slide. We need this experimental for experiment materials and equipment. It's where first of all is collected this equipment and the materials. We use materials I mentioned before, just raw materials in our country. Just firstly, materials, the raw materials used were cellulose obtained from miscanthus and pepper tree. Acid, alkalis, and solvents we are used as a chemical treatments. Equipment. One slide before I told this the three types of equipment, and the methods. The practice size was determined dynamic light scattering. Just morphology was studied by electron microscopy. Okay. You can see just the first and second is our experiment results. So various materials, equipment, we use experimental part of study. Technical pulp, acid, alkalis, before solids, we were used processing high pressure. Just carefully, just firstly, just high pressure gamma ionizer, just ultrasonic, this spares just centrifuge is this dosator. This we use the experiments. Next slide is we obtained the cellulose three type of methods. We compared this every results for you can see just methods chemical, mechanically combined. This particle size is different. This morphology, its properties, costs. We choose last one combined methods. That's why it's first of all is low costs and just size where size nanocellulose size. Our research is for suitable. So next slide, just you can show that application areas of obtaining nanocellulose. You can see just very popular application of cosmetics. Women knows that this cosmetics prepare just naturally is for health or for body is very suitable. So medicine, cosmetics, composite materials, being just currently we use only nanocellulose only uses paper materials, just paper, just in secretly just I use nanocellulose. I use money paper. Money paper, just that's why it's very comfortable. Just in chemical side, this properties, this mechanical properties from just hydrogen bonds. So okay, just maybe we science we have no doubt this products promising. I mentioned above just in areas that currently interested everyone and has forced that work. Just Professor Levent Trabzon told before, just nanocomposite or nano materials is very important. This currently every country. So next slide is, I told this before, just economic assessment is prospects. You can see just three types of percentage: cost reduction, marketing growth, and the increase in productivity. Thank you so much. I have done. If you have a question, I try to explain. Thank you.
Any questions from this here?
Just slide this, my contact. If you have a question after the meeting, contact me every time. 24 hours I work my contact is work. So
Any questions, any comments regarding the yeah, please.
if you have a recommended
Thank you for your presentation. Welcome our university. I have a question. Can you explain how can you obtain nanocellulose? First step was homogenization and second was grinding, right?
Uh-huh. Okay. Just
Previous, I think.
sorry, just.
Yeah,
Mm-hmm. Nanocellulose firstly, just currently in our research, just firstly obtaining cellulose. After then, grinding just is cut fiber. After then is ultrasonic just treatment. My student use is research just a very important equipment, ultrasonic treatment for
Actually,
me.
I cannot understand. Firstly, you break what?
Break down this from nanocellulose. Just cellulose, you know that this, cellulose is fiber, natural fiber. Fiber is firstly just size, big size cut. After then is grinding. After then is very small, just nano sized fiber.
How can you grind the broken ones?
Just first one is size centimeter. Centimeter. Next one after then is millimeter, and this nanometers.
Thank you very much. Any other questions? Any comments? Yeah. Yes. Next.
Thank you, Professor. Welcome coming here. I have a question about, first actually, it's about the motivation. What was the, your idea starting with this research topic? Is that because you guys have a lot of like rainforest or basically green supplies that can be turned into the nanocellulose? Or it's just the, basic science aspirations?
Okay, thank you. So thank you for the question. Just our research just belong to the a little bit politics. Every year, my president put this name, just every year. In our this year, in our country, this ecology and environmental protection and green economy. That's why I choose this topic. That's why it belongs to this politics.
Okay, the next part is, it's kind of like recommendation and also like, is a comment. It's about the nanocellulose production. Thanks for showing us, because before joining here, I was part of University of Michigan back in United States, and a lady from my group was working on the nanocellulose, part, and how they can use this one to increase the strength of the composite materials. And at that time, they accidentally discovered that when they feed this nanocellulose particle to the plants in order to grow a fiber, then they're gonna use this fiber to get composite materials.
Composite materials.
But the thing is, when they feed the plant with this nanocellulose, they discovered that the plant itself performed better. It was kind of like fertilizer instead of being a strength of the material. So they immediately file a patent for this one. My question is, say, in the future, if they want to collaborate with you, what should they do? Or do you guys have enough supply of nanocellulose for them?
Okay. In the future, we will together. A professor told me just sometimes your university will use this sphere. That's why in the future including this nanocomposite materials and use all sphere. That's why I use. Firstly, we use nanocomposite material, nanocellulose, just use paper and other field just in the future. So you recommended.
Okay, I guess I have partially get my answers.
Thank you.
It's a new field.
Yeah.
It's a fertilizers.
Yeah.
Very good. Because we are working on the quantum dots, C base or N dot or potassium dot or phosphor dot, used as a fertilizing. Now we have an ongoing project, but we haven't utilized nanocellulosic, the material as a fertilizer. It's a good point. Thank you very much. Dr. Asawa, your question.
Thank you very much. It's very informative presentation, but I have two questions to be answered, if possible. First, application area for this kind of paper, because I feel it is very expensive, the processing of paper. And if you can compare the cost of this type of paper with other type of paper produced by other means or other processes, that will be good, because you are using expensive materials like chitosan, basalt. This is one question. Other question is about nanocellulose and the type of processes you are using, the mechanical process, grinding, homogeneous, and the chemical process. I ask you if you use any green method for making nanocellulose, or if you come across any processing using green methods like bacteria or herbal processes. Thank you.
Okay. First of all, I thought this my start this presentation as my research is not expensive. We use raw materials. Raw materials is firstly just annual plants this treatment. So basalt fiber, just long fiber, use construction materials. Not construction materials is used as fiber just, treatment. We use paper. This why it's not expensive. Just cheaper than other materials. So next one, I remember it.
The application.
Yeah.
The area of application for paper.
Yeah. Currently, just I use it only just application for paper. After then, is we use.
For what? Used for what kind of paper?
Just paper, just not swilling, just oil and water.
For filtering.
Just yeah.
For
Filtering.
Filtered.
filter.
Yeah.
Filter paper.
Yeah.
Nanofiltration or
No, just
just
yeah,
filter?
just a filter.
Micro-size
Yeah. Yeah.
filter? Okay. So
For users, oil just clean this oil products for user filter materials.
for oil,
Yeah.
cooking oil,
No, just
what type of oil?
oil and gas industry. We use filter materials for clean this oil. Understand that?
For filtering oil. So
Yeah, yeah,
it's
yeah.
Microfiltration, bacterial type
No, just
type of impurities.
micro size filter, just not nano filter or bacterial filter.
Microscale.
Microscale.
Yeah.
Yes.
Using chitosan.
Chitosan is why I use the chitosan. Chitosan is give me properties is for strength, yes, for paper. Only surface on the paper surface. Yeah. Cutting, yeah.
And basalt for strengthening?
Yeah.
Mix. How do you mix basalt with?
Just percentage, just 25 basalt fiber,
25%.
25% is 75% is cellulose.
It's
No,
not
no,
going
just-
to be flexible. It's not going to be soft. Basalt, it is mixed.
Yeah, three type of the basalt fiber. Just I use it very thin. Yeah. Maximum percent is 25. Yes.
Micro-size, you mean?
Micro size. Yes.
Micro-size.
Yeah.
How do you make it micro-size? Because normally it's mixed. Sorry. How do you make it
Just
micro-size? Do you grind?
We so just chemical sides. We saw that a donor acceptor bond we use. This why is mixed.
How do you bind basalt with cellulose paper? Binding. How do you do the binding? Bonding.
Yeah. Just yes, we and just only you know that is paper making just only two types of basalt fiber, not adding other chemicals. This is why you use in the making just bond, chemical bonds.
Chemical bonding.
Yeah.
Thank you very much. Any other questions from the audience or from the room over here? Adnan? No? Okay. I think we should thank our speaker one more time.
Thank you.
Thank you very much for joining us today. Hopefully we will have another, the seminars, mechanical engineering department seminar, and you will join that as well. Thank you very much.